Hello everyone, today we're going to be talking about trapezoids and kites. In this first video we're going to be talking about trapezoid and in particular the isosceles trapezoid. So first, just to kind of go over this shape, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So for most of this unit we've been dealing with parallelograms and special parallelograms. And what we learned with parallelograms was that they have two pairs of parallel sides. However, with a trapezoid, we actually only have the one pair. And so if you look at this picture here, we see we have these arrows here that represent that these two sides are parallel to each other. However, we can clearly see that these two legs are not parallel because we'll see if we extend both these out, they'd eventually intersect. And so we have different types of sides that we see in a trapezoid, and we call them certain names. First, there are the bases, and these are the parallel sides. Next, we have the legs. These are the non-parallel sides. And you can see these all labeled in this image right here. And then the base angles are the consecutive angles whose common side is a base. So in other words, the base angles are those angles that are right next to each other, that between the two is a base. And so we see these are all base angles. Now an isosceles triangle, or isosceles trapezoid, is a special type of trapezoid, and that is when the legs of a trapezoid are congruent. So I can see, for instance, this image right here is not an isosceles trapezoid because I can see that this leg is clearly not congruent to this leg. And so an isosceles trapezoid would look more like this, where these two sides are congruent, and then these two are my parallel sides, are my bases. And so there are a few theorems that we have about isosceles trapezoids. The first is the isosceles trapezoid base angles theorem, and that tells us if a trapezoid is isosceles, then each pair of base angles is congruent. So this isn't the case for a normal trapezoid. This is only for an isosceles trapezoid. And so I see that my base angles A and D are congruent, and I see that my base angles B and C are also congruent. And remember, those base angles are those angles that are right next to each other and they share a base, which is one of the parallel sides. And then we also have the converse of that theorem, and that says that if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. And then we have the isosceles trapezoid diagonals theorem, and that tells us if a trapezoid is isosceles if and only if its diagonals are congruent. So here I see that this is isosceles, and I know that because of my legs being congruent. And so because this is an isosceles, I could then say that AC is congruent to BD, so my two diagonals. Okay, let's do two examples of using properties of isosceles. So for number 1, it says to find the measure of each angle. And here I know that this is an isosceles trapezoid, because first I know it's trapezoid since it has the one pair of parallel sides, and then I see that my legs are congruent. And so we learned from the base angles theorem that means, since this is isosceles, that each pair of base angles is congruent. And so that means that angle B is going to be congruent to angle A. Remember, it's the base angles are those that share a base between them, or of that side. And then we see that angle C is going to be congruent to angle D. So that means that angle D, I automatically say, is 100 degrees. Now I need to figure out what these other two angles are. And so an easier way to do this is that we know that these two angles here, these consecutive angles, are going to be supplementary. And so to figure out what measure of angle B is, I can say measure of angle B plus 100 is equal to 180. And then I can solve. So I get that the measure of angle B is equal to 80 degrees. And then I already know that angle B is congruent to angle A, and so that means that the measure of angle A is also equal to 80 degrees. Okay, let's try another one. So here I want to find the measure of each angle. First, I notice that this is an isosceles trapezoid because they have congruent legs, and so that means that my base angles are congruent. So that means that angle E is going to be congruent to angle H. So that means measure of angle E is equal to 49 degrees. And then I also know that angle F is congruent to angle G. And I know that angle G and angle H are supplementary, so that means that the measure of angle G plus 49 is equal to 180. Subtract 49 from both sides, and you get that the measure of angle G is equal to 131 degrees. And since angle F is congruent to angle G, that means the measure of angle F is also equal to 131 degrees.